Okay, so this is Unit 2. Unit 2 was logic. And one of the early things that we talked about in logic were different logical fallacies. Okay, now what I think is going to be helpful when you're taking a test on this, in this current format that we have, your tests are open note. You can use your notes for tests. Okay, so when you go to your final exam and you're looking at these logical fallacies, don't be afraid to have your notes handy to reference so that you can identify the logical fallacies. Okay, it can be, I think, difficult to try and remember everything. Let me pull up the notes real quick. And trying to memorize everything isn't really the goal of what we're trying to accomplish here anyway. So we'll look at our notes on logical fallacies. Okay. And we talked about them, and I think that we had a list. No, we didn't list them. Okay, we just kind of wrote them each as we went. Okay. So we had fallacies of relevance, right? So the ad hominem personal attack, an argument from authority. Okay. And then we had an appeal to incredulity, an appeal to consequences. Okay, fallacies of misinterpretation, right? So what we want to do is have this sort of handy as we go through to identify what our logical fallacies are. So we'll just go through a couple examples here. If my crush is in love with me, I will be happy forever. Therefore, my crush must be in love with me. Okay, when I think about what we're doing here in this logical fallacy, we're assuming something is true because we want it to be true. Okay. So if we need to go back and read, what are these, different things? See if I can pull these up side by side here. Too big. Okay. So if I look at appeal to consequences, an appeal to consequences, a claim is true because if it were false, something bad would follow. Or because if it were true, something good would follow. That kind of sounds like what we have, right? We're saying that something is true. We're saying that our crush is in love with me because we like the consequences of that. Okay. All right. Let's just go through the others real quick. We could look at the others, right? False dichotomy. False dichotomy assumes that one of two things must be true, when in fact there might be other options. So in false dichotomy, we say it has to be this because it's not the other thing, and that's making the assumption that there's only two options. Okay. Well, that's not really what we have here. Let's see, equivocation. An argument relies on equivocation if a key term has a different meaning in the premises and conclusion. Okay, so if the word love was being used in different ways, that might be equivocation, but it's not here, right? We're talking about your crush being in love with me, a crush being in love with me. That's the same use of the word love, so that's not equivocation here. Okay, slippery slope. A slippery slope argument claims that an action shouldn't be taken because it leads to further actions without extra evidence. Okay, so in a slippery slope, we're saying, oh, you don't want to do this thing because then because then somebody will make these other choices later. Okay, and that's not what we're doing here. Okay, and then finally, an appeal to authority. Appeal to authority is a good name because I feel like it really sort of sums up what it is. In an argument from authority, one claims that a statement is true because it came from someone that's good or reliable. Okay, but that's not what we're having here. So this first one is definitely an appeal to consequences. All right. Requiring that children be vaccinated in order to attend public school? What next? Soon they'll be taking your kids away if you don't let them eat at McDonald's. So what we're doing in this argument, right, even though it's phrased as a question, right? It's an argument somebody could make, is we're saying, okay, we have one decision, right? Children have to be vaccinated in order to go to school. And then we're then going to assume that somebody's going to make another decision later, and that other decision we find ridiculous. Okay, so the other decision is they'll be taking your kids away if you don't let them eat at McDonald's. Okay, so I think that the idea here is that we start with something that we don't like, and we argue that it's bad by saying something worse will happen later, not because of what you did the first time, but because of making another decision, right? So it's like your decision making is getting worse and worse, right? That's, I think, the idea of this slippery slope. Okay. The difference between a slippery slope and, say, an appeal to consequences is in an appeal to consequences, we're looking at the consequences of this one thing. In a slippery slope, we're saying, if you do this one thing, then other things will have, we'll make these other decisions later. Okay. So the appeal to consequences is looking at the consequences of this one thing we're talking about. In a slippery slope, we're not looking at the consequences of vaccinating your children. We're looking at this whole bit about taking your kids away. All right, next one. You can't vote for the female politician because her husband cheated on her. If she can't satisfy her husband, how could she satisfy the demands of office? All right, and this one is tricky. If this one had like an ad hominem attack, I might be tempted to think of that as like a personal attack, but that's not in this list, so that helps narrow it down a little bit. The key thing here is that we use this word satisfy twice. Okay, so she can't satisfy her husband. That's one use of the word satisfy. She can't satisfy the demands of office. That's talking about something very different, right? In this context, when we talk about satisfying her husband, we're not talking about the same things as when we say satisfying the demands of office. So we're making a connection by using the same word, but we're using that word with completely different meanings. Okay, and that's what an equivocation is, right? We're switching our definition of a word, but we're relying on it being the same word, right? If you changed the word, then suddenly it would feel like there's no connection between her cheating on her husband and her being in office. Okay, so we're making that connection by using the same word twice, but we're using the word in different ways. Okay. All right. Next, I want to look at a truth table. See if we have a more complicated area. Well, okay, so let's look at a nice big complicated truth table and how to fill this out. So I'm gonna talk about this problem specifically, but first I want to talk about truth tables really quickly. And let's see if I can pull up. Okay, so what I'm doing now is I'm going to pull up the notes from section 2.3. Make them nice and big here. This is, I believe, the last page of the 2.3 notes. And what we have here is a basic truth table for each of our connective statements in logic. Right? Our and, or, if then, if and only if. And what this does is it gives you the instructions for how to combine two truth values using a connective to get a new truth value. Okay. And I'm going to show you what I mean. In the example that we have, these are all if-thens. Okay, so that's what we're going to be using. But the if-thens are the most complicated ones, so I definitely want to have that in my example. Okay, but the idea is that we can sort of ignore the letters here, the P and the Q. We can just say, okay, if I have an if-then, if I'm combining two, true and true, right, I get a true. Now, for the other ones, the order doesn't matter, so you really could just say, a true and a false, right? When I'm using the and, I get a false. When I'm using the or, I get a true. For the if-then, the order matters. Okay, so, is the P first or the Q first, or is it true then false, or if false then true? Okay, that matters. For the other connectives, it doesn't. Okay, so when we're going through and analyzing a truth table, let me just get this set up. What we want to do is look at what is it that we're connecting and in what order. In a truth table, we're only either going to be negating a column that we already have exists, or we're going to be taking two columns and combining them with a connective. Okay, so there's no work to do in your head. There's no remembering stuff. The only thing that you have to remember, or you could just reference, is this little chart here. So what we need to do is make sure we know how to use this chart. Okay, so the first thing, it says if P then Q. So I'm going to use the P and Q columns, and when I'm doing this on a page, I like to run my fingers down the columns to match them, but maybe to help here, I'll highlight them. Let's make that bigger. Okay, so I'm going to highlight the columns that we're going to be using. So I have the P column, that's my first one, and then the Q column is my second one. Okay. So if I have if true then true, let's get this back here. Looking on my little cheat sheet, true, true with the if then gives me a true. Okay, so I know that my first entry here is going to be true. Okay, I have this repeated, if true then true again. Okay, if true then false. So I go to my column, or go to my cheat sheet, and I say if true then false with the if then gives me a false. Okay, if true then false, that's a repeat. Okay, if false then true. Notice that for the if then, if you start with a false, either way, if it's if false then true or if false then false, the if then gives me a true. Okay, so starting with a false and the if then gives me a true. Okay, now when the order starts changing, that's where things can start to get complicated or confusing. So again, we're going to be careful with this. So I'm starting on this. Oops, let's keep our old stuff. Just erase the highlights. Okay, so I'm going to start with Q. I'm going to do if Q, then R. Okay. So it starts off if true, then true, right? I know true, true, if then gives me a true. True, then false, that gives me a false. Starting with a false on the if then gives me a true. Starting with a false on the if then gives me a true. True, true gives me a true. True, false, that's where we get our false. Starting with a false gives me a true. Starting with a false gives me a true. Okay. It gets even more tricky, I think, when not only, are we not using if P then Q, right? We have this R in there, and also the direction changes here. So if I start with R, if R then P, Okay, then we have to be extra careful. Okay, so I'm starting with the R. So if R, then P. Okay, so if true, then true, right? You know, the double true I know gives me a true. If false, then true. I'm starting with a false, and the if then gives me a true. If true, then true gives me true. Again, starting with a false gives me a true. If true, then false. Okay, that's the row where we get a false on our if then. Okay, starting with a false gives me a true. If true, then false. Again, that's the one that gives me a false, and then the last one I start with a false. So the if then is true. Okay, so that's how we can go through and use this little table here. It just tells you how do you combine two things using your connective. Okay, and we can use it for all of them. We also talked out how to do these, right? You can think of the if and only if as do they match, right? Two trues match, so I get a true. If they don't match, I get a false, right? Here they don't match, so I get a false. Two falses match, so the if and only if is true. The and statement, they both have to be true, right? The first is true and the second is true. Okay, then I get a true. Here it's not the case that the first and second are both true, so I get a false. Okay. For the or, I need either the first one true or the second one true or both true for the or to be true. Okay. So double trues give me a true, just one gives me a true. Okay. It's only when they're both false that the or statement is false. So that's another way to reason it through. But if you're ever at all confused, you just come back to this little table and it shows you this is how you combine two things using that connective to get a third thing. Okay, so that's going through truth tables. All right, let's finish this problem. Consider the argument, all dogs are mammals, all mammals are animals, therefore all animals are dogs. So we've symbolized the argument, okay? It doesn't ask us to do a conclusion, but I'm just going to go through this really quickly. So we symbolize the argument, if P, then Q. So if it's a dog, then it's a mammal. Okay, all mammals are animals. So if it's a mammal, then it's an animal. Therefore, all animals are dogs. So if it's an animal, then it's a dog. Okay. So then, you know, we fill in all of our truth values. Okay. And what we're doing with this is an argument should be that if all of the premises are true, then the conclusion is true. Okay. So if the statement all dogs are mammals is true, and the statement all mammals are animals is true, then the conclusion should also follow and be true. So what we would do here is we would look at this and say, well, here I have the first premise true, the second premise true, and the conclusion true. Okay, that checks out. This next one of my premises isn't true. Okay, then the conclusion can come either way. Okay, here one of the premises isn't true. Okay. Here one of the premises isn't true. Row 5, though, I have both premises true and the conclusion false. So it's logically possible for me to have all of my premises be true. All dogs are mammals, all mammals are animals, and also I could have my conclusion be false. My conclusion is all animals are dogs, and that's possible to be false even when these first two are true. So that would tell me that this argument is an invalid argument. Okay, and it's, you know, row 5 is the key there that tells me that. Although row 7 also does that, where I have true premises but a false conclusion. Okay, that's not part of this particular problem, though. That was just maybe going a little outside it. Should we do one more? I think we should do one more logic one. Let's see. Okay, well, we're going to do one like this. Which disjunction is equivalent to, if not P, then Q? If you're not prompted to fill in a truth table, you're not going to be expected to fill in a truth table. Okay, so we could fill in truth tables for something like this to find an equivalent statement. Okay, but remembering back to the logic, some of that work that we did, we don't want to have to repeat. So what I'm going to do is I'm going to open up my section 2.7 notes on equivalent statements, and I'm just going to go to the very last page, and that's where we summarized a bunch of equivalent statements. Okay. And this is what we can do. I think this is like a good reference, especially for like an exam, for things that are equivalent, right? So the first one on here, you shouldn't need to reference, right? A double negative, they cancel each other out, right? The double negative is the same as the original statement. But I think for most of these on here, we want to make sure that you reference them to make sure that you get them just right. So it says, which disjunction is equivalent to, if not P, then Q? A disjunction is an or statement. So I want to find an or statement that's equivalent to this if-then statement. Okay. So what I can do just to sort of, glance through this and, figure out what I might, want to even consider, I want to look for equivalence where I have both an if-then on one side and an or statement on the other, right? So like here, this is, both of these are if-thens. Here I have and or an and, okay? But here I have an if-then and an or statement. Okay, here I have an if-then, but this is an and statement. Okay, so that's not really what I'm looking about. Here I have a lot going on. There's if-thens and ands and if and only ifs, but it's not an if-then on one side and an or on the other. Okay, this one has an and statement, but it's got these compounded if-thens. That's not really what I'm looking for. And on the bottom is just the symmetries. It's saying and statements, or statements, and if-then, if and only ifs, are the same both ways. Okay, so this looks like it's probably going to be a conditional exchange, except that it doesn't start off exactly the way I want my left-hand side to be. In the conditional exchange, I have if P, then Q. On what I'm looking at here, it's if not P, then Q. So there's more than one way to go about this, but I think that the way that makes the most sense to me is to do a substitution like we do in algebra. I'm going to let capital P equal not little p, and capital Q equal little q. Okay, so then the negation of P would be the double negative of little p, which is just P. Okay, and I'm writing equals here, right? These should really be equivalent, but I don't think that makes that big a difference. Okay, and likewise, not Q is going to be equivalent to not little q. So what we're going to do is we're just going to substitute here for my little letters for my big letters. Okay, little p is equivalent to not big P. Little q is equivalent to big Q. Not little p is equivalent to just big P on its own. I'll leave the or statement. And then Q is equivalent to capital Q. So I've just changed from little letters to big letters, which hasn't really changed things by much. But now I can see a nice equivalence where the left-hand side matches what I have in on my reference page. Okay, so I have if not P, then Q, and that's equivalent to P or Q. So I would say, oh, okay, I found the answer. It's P or Q. Okay, so again, that's something that I think that you want to have practiced, recently before you take the exam so that you don't get yourself too confused. particularly the substitution bit.